Okay, welcome back for really day one of conics. In the previous video, I quickly outlined why they were called conics, um, letting you realize that we can look at it geometrically or also in terms of a locus definition, but of course the equation. And we started with the very basic conic of a circle, which you hopefully know a lot about. The second conic is also something that you should know a lot about, and that is a parabola. You might remember in the geometry description of a parabola, it's when that plane that's slicing the cone does not kind of make a closed figure. The locus definition is something I have on the front board, but you also know a parabola simply as the graph of a quadratic function. So you don't want to forget what you already know about parabolas. We're just going to look at them maybe from a different perspective. Our locus definition for a parabola is simply this: a set of points. I'm going to just assume that we know all of these are in a plane, so I'm not going to continue to write that. But equidistant from a fixed point and a line. And I should use a T instead of a D. Now, let's start, maybe look at a picture of this. If this happens to be my line, and this is my fixed point, and I think of all the points equidistant from those two, well, one very obvious one is going to be right in between. So we might say that this distance and this distance are the same. Now, if I continue to find points that fit this description, one might be right here, where these two distances are the same. One might be right here, where these two distances are the same. And likewise down here and over here. And it would just keep going and going and going. So what I would end up with is this figure. And of course we know that to be a parabola. Make that a little bigger. Make that one a little bigger. Now, just as with a circle, there are certain things that we want to name. What do we call that fixed point? Well, the fixed point, of course, is going to be this new word that we have. It's called the focus. That line is called the directrix. And then this point right in between, of course, we call that the vertex of the parabola. Now, there are some other things. We're going to label that distance between the point and the vertex, or the line and the vertex, as just simply A. It's going to be some constant. Okay? And then we even have a name for this value from this point all the way down to this. And that is called the latus rectum. From here all the way down to here. It's that whole distance. So that's kind of the breakdown of the locus definition of parabola. Now, of course, we could have a parabola that's situated up like this to the right. We could have it to the left. We could have it open upward, open downward, all depending on where these things are. Now, your goals are going to be pretty much the same as with the circle. You could either be given these specific pieces of information, you have to write the equation. You could be given the equation, you have to pull out that specific information, or you could be given a graph and you could figure out the specific information and then, of course, write the equation. So let's take a look at what the standard or various form of a parabola should be. Then we'll get to some examples. One way to write a parabola this is where it's going to look a little different from your normal, ax squared plus bx plus c equals y. That's more the quadratic form. One way to write it would be y minus k. And then we have to decide how we want to incorporate the square. And I'm going to isolate the squared term. And our other option would be x minus h squared equals 4a x minus k. Now both of these can be transformed so it's in your more normal version of the quadratic. But the reason we like this is I sometimes refer to it as a user-friendly form. Because if it's in this form, we can easily see what the center is. And because of that a, that corresponds to this, we can get a feel for some of these other things when we're trying to graph them. Now this first one is going to be either open up to the left or open up to the right parabola. And this other one is going to be open upward or downward. Again, here the y squared, here's the x squared. So let's take a look at some examples. Now let's do it here. Let's find the equation of the parabola with the focus being 0, 4, directrix y equals negative 4. Okay, so we're of course using this locus definition. I'm going to get a quick sketch so I have a better idea of what's happening. If I just put this on the xy axis, y equals negative 4 is going to be this line. So that's my directrix. The focus is 0, 4. So if you understand the geometry of this, you all already very quickly know where the vertex is. And by the way, the vertex, of course, is going to be given by our HK. Okay, not really the center, because a parabola doesn't have a center, but it's similar to what we would have with the circle. So I pretty much know that. Because of how this is situated, the vertex has to be basically the origin. Okay, that is my vertex. So if I would continue to draw the rest of the parabola, I would just have this. Now we also notice that this thing is an up-down type of parabola. All right, so it's going to be this form of the equation. And we also know A, simply by looking at the picture. A is 4. So without too much trouble, I know that the equation of this parabola will simply be x minus 0 squared equals 4 times a, which is 4, times y minus 0. Now, we don't need all of that, of course. We could just write x squared equals 16y. And if you would graph that equation, you would hopefully see this type of a parabola. So that's a pretty basic example. Let's find another equation. Vertex negative 2, 3, focus 0, 3. So same expression, or same directions. Find the equation. Vertex negative 2, 3, focus 0, 3. So again, I'm going to sketch it because I like to see a picture. Vertex is negative 2, 3. There's my vertex of my parabola. Focus is 0, 3. That's my focus. So already things are pretty much determined. If that's the focus and that's the vertex, well, this directrix, if I did have to draw it, even though I wasn't required, would be this. So a lot of information is given. I already know the vertex, so that's going to be used in the formula that I use. I also know A. That distance is 2. So I don't really use the focus in the equation, but it's used to help me get A. I also know which of these two categories I'm going to make use of. This is kind of a left-right one, so I'm going to use the y minus k squared version. So my equation, without too much trouble, is y minus k remember that's this value, 3, squared, equals 4a. A is 2 times x minus the x value, not squared. So we get y minus 3 squared equals basically 8 times x plus 2. And we may keep it like this. Now, if for some reason we don't want to keep this and keep the equation in this form, we can easily distribute, expand the terms, and put it in a more common way of writing an equation. But this is a better form because we understand it in terms of the graph. It's easy to pick out the vertex and so forth. Now, I've picked one that was open upward and open up to the right. If it's opened up to the left or downward, we know that there's got to be a negative coefficient in there. And it really comes down to this A. So anytime we have, we're moving from the focus to the vertex in this way, that A is going to be positive. If we change directions, we would just have to make A negative. So that's a minor variation. Another type of problem that we could see, of course, is where we have to complete the square, kind of like we did with circles. So we might be given an equation. I'll at least get this set up. And then we have to understand all the details. Let's say it's x squared plus 4x minus 4y equals 0. Let's say here the instructions are to just find the focus, vertex, and directrix. So find all the particulars of this. Well, in completing the square, I'll take these two terms. Half of that is 2, square it and add it. So I get x squared plus 4x. Half of it squared is still 4. Now I'm also going to put this 4y to the other side. And since I've added 4 on this side of the equation, I'm going to have to add 4 here. So now here we have our x plus 2 squared. And if I want to rewrite this, I can factor out a 4. So as I take a look at this equation and then compare it to one of these two, I realize it's like the bottom one. So without too much trouble, I think I know the vertex. The vertex is going to be -2, -1. So that would be the vertex of this parabola. If I wanted maybe the focus or the directrix, I would have to know A. And in this problem, A is going to be 1. So it's basically, you know that I'm moving one unit, one direction from the vertex. I just have to decide what. Well, again, because it's this one, because that's positive, I know it's an upward type parabola. So if the vertex is -2, 1, sorry, -2, -1, that's the vertex, the focus is moving up 1. So if I just move up 1 unit, I'm at -2, 0. So there's the focus. The directrix is 1 down. So if I move 1 down, it's at -2, and the directrix is a line. Now I know this example I went through rather quickly, but I just wanted to be complete about some of the things you're expected to do. So I know that was a lot for this first day. Really for about the next week and a half, we're going to be looking at conics. So dealing with the section 2.3, which is about circles, 11.2, which is dealing with parabolas. You should have plenty to do over the next several days. At the end of the week, we'll look at the hyperbola and the ellipse. But those are a little bit more involved, so we'll kind of space them out a little bit. Good luck with this. As always, let me know if you have any questions.